Good morning, everyone. How are you after the party? Yeah, all ready to rock and roll with some deep dive troubleshooting. So just a matter of interest, how many of you came on yesterday's session? Well, that's great. So you know everything there is to know about OAuth2 and OpenID Connect, and you remember everything. So what I'm actually going to do is I'm going to start off today with just doing yesterday in about 10 minutes, just to bring in the key points, because I want to know, set a level that we can jump from, okay? So a quick sort of intro to OAuth2, OpenID Connect, but it is going to be quick. And then we're going to start looking at some troubleshooting tools and maybe the best tools that we should be using. Looking at tracing. Tracing is so important. If you don't turn on tracing, you can spend hours. And those hours turn into days before you fix the problem. Put a trace on, and it could be a matter of seconds, and you've gone, that's what it is. All right? And I'll go into where those sort of issues come in. And then testing token validation. I've found through experience that quite a lot of times you get an app that's delivered and it's not validating the token correctly. So I want to show you a way of how we can actually set a breakpoint in Fiddler. And, well, I guess it's the wrong term in Fiddler, but we can fiddle with a token, which will then tell us whether the token is being properly validated. And then I want to look at the importance of back-channel tracing. Well, what is back-channel? We'll have to come to that. And then I'm going to go into a little bit more detail of consent and show you how you can actually enumerate consent out using PowerShell. So we'll look at how consent, well, things that are being consented to, is actually held in the directory. So, starting off, just as a reminder of our OAuth2 protocol. So we have App 1 and we have App 2. App 2 is likely to be a web API. It may well be a REST API. And the one thing about a REST API, one thing to remember is that it's stateless. So if you're thinking, can this REST API do something? Just remember, it can hold no state. And what happens is we want App 1 to access App 2 using the user's identity, but with a limited set of permissions. So what we get is an access token, and in that access token will be permissions that the user has consented to. And that token arrives at application number 2. Application number 2 says, aha, this user is authorized to access me, as in, how do we know it's me? Because in the token, there is an audience parameter. And that's one of the things we should be checking. So we now know this token is for me because the audience matches. And what can that user do is set in the scope. All right? It doesn't necessarily mean they can do it, though, because I might make some other authorization decisions, which I will come back on later. So remember, OAuth2 is about allowing one app to gain access to another app with a set of consented to permissions. Right? It's an authorization protocol, not an authentication protocol. If we look at the App 1, and this is the beauty of OAuth2, could be all sorts of different types of applications. So mobile app, it could be a native app sitting on a desktop. It could be a single page application sitting in a browser, which is being run by JavaScript, all right? Or it could be a server sitting in your data center where the user connects to with a browser, i.e. a website. So we can cope with all these different types of applications. And depending on your application, you have to go and request a token in a different way, and that is referred to as a grant or a flow. So when someone says to you, oh, it's an OAuth2 grant, what it means, it's an OAuth2 method for getting a token. All right? And depending on what type of application it is, you use a different method. as I say, the access token is purely for consumption by the second. I was just trying to think which way round I am. Yeah, it's purely consumption by the web API. Oh, and one other thing on there, which I should mention, is we could go from app 1 to app 2, not using the identity of the user, but using the identity of app 1, in which case that's referred to as a client credential flow, and the identity of app 1 is actually the app 1 service principal. That's where the identity comes from. OpenID Connect layers on top of OAuth2, and what it does is it gives us an ID token. So now, when we come to the front end, we come with an ID token, and that proves the identity of the user to the front-end web server. So if we look at the ID token, the audience on the ID token will be this front-end web server. And then we can have this consent that's triggered, all right, and the user consents to this front-end web server having an access token. And the access token, remember, the audience will be the target application. Formats for these tokens, the OpenID Connect standard absolutely mandates a JSON Web Token format. The OAuth2 standard doesn't say what the token should look like at all. Right? Microsoft have decided to use a JSON Web Token for the access token. So JSON Web Token format for the access token itself. Right? Others don't. So Google, for instance, when we go to a Google API, we'll use an access token, but it's a proprietary token which you can't look inside. Right? But remember, App 1 can look inside the access token, but absolutely shouldn't. It should treat it as a binary blob, right? Because at any time, the implementation could possibly change, but there's nothing inside that token that is relevant to App 1, and that's really, really important. So the audience on that access token is App 2, and that's the only person that should be consuming it. And this guy, App 2, is going to take that token, and it's a contract between the authorization server, which is Azure AD in our case, and the backend API. JSON Web Token format, I'm just going to go through it again briefly because we're going to be actually troubleshooting with this. 3 components. We've got a header, we've got a body, and then we've got a signature. Right? The header is separated from the body by a full point, and the body is separated, the header is separated from the body with a full point, and the body is separated from the signature, again with a full point. So you know the actual, where they're demarked. And the body is a JSON document. So it sort of self-describes what the data is, and it's sort of almost readable. Aud is audience, ish is issuer, IAT is issued at, NBF is not before, expire is when the token expires, and that is, as I said yesterday, is it's in epoch time, or you can describe it as Unix time. So it's the time since the very 1st of January 1970, and that's in seconds. Refresh token, really, really important to us because we've got application 1 now has an access token for going to application 2, and we want to revoke it. Well, bottom line is we can't revoke it. All right? The reason being is this guy, app 2, could say, oh no, that token's been revoked. But to do that, it would have to be stateful. So it would have to look that token up in some database or do something with it to reject that token. So because it's stateless, he can't reject it. If app 1, the front end, has got a token, does he want to give it up? Maybe he's gone a bit rogue and he's got that token. So the solution is to have a very short lifetime on the token. Lifetime is 1 hour, but we have a refresh token, which by default, the lifetime under most situations is indefinite, provided it keeps being reused. And what you do is app 1 says, oh, my access token to app 2 is about to expire, what I'll do is go back to the AS, the authorization server, well, Azure AD in our terms, and say, please, can I have another access token? And if you've been revoked, the answer is no. And then we sort of looked at this very briefly, but this is the flow I'm really going to dig into today. So we have a resource owner, hits the application. Remember, the application says, looks to see if you're authenticated. How would we know if we're authenticated to the application, or how would the application know? What would it have? A cookie, yes. So if it's got a cookie, then we won't have to go through this, what I call a federation dance. But with no cookie, what's going to happen is we're going to shoot off up to Azure AD to an endpoint. All right, we'll have to find out where we get those endpoints from. Having shot up to Azure AD, what we're going to do then is request, and there's going to be a complex request string, and we're saying, please authenticate this user to this application. All right, but it's way more complex than that because there's lots of things we can ask for. So do we want the ID token back? Do we want a code back? And so on. Have you, you've a question? Well, we can, yeah, throw a question in. If, very, very good question. Brilliant question. How does app 1 know the token's about to expire if it's not allowed to look in it? So when you get the token back, you also get metadata back, which gives the token lifetime. So what you do is you put the token in a cache. You don't look inside it because it's not yours, but you store the metadata with it. So now you know when it's going to expire. So thank you for that. I will point it out to you when we get there. So we've gone up to the authorization endpoint, and we've got this complex string that says exactly what we want. And this guy's going to say, okay, are you authenticated? Well, do you have a cookie? Have you authenticated to the identity server? No. So what we're going to do is we're going to make you authenticate. And if necessary, if we need to consent, we'll be prompted to consent at this time as well. We don't have to have users consent because we can have admin consent. And having done that, what we do is return a cookie. It's not one cookie, it's lots of cookies. We return the cookie, we return and what we've been asked for. Well, in this case, because it's hybrid flow, we've been asked for an ID token to the front-end application and a code to the, which can be translated into an access token to a back-end resource. They come back, and now this guy, the application server, the front, is going to go off up to Azure AD to a different endpoint, and this is called the token endpoint, and say to Azure AD, hey, I've got this code, please give me back an access token. And when he goes up there with a code, he's also got to identify himself. So what he'll have is he'll have his client ID, and remember, Microsoft call a client ID an application ID, but think of them as exactly the same thing. So we have an application ID in the Microsoft space. It's actually on the protocol. It's a client ID. And you'll supply your client ID, and you'll supply your client secret, which is your password. Microsoft call that a key. Right? There are ways of actually using public key, so actually certificates as well for the authentication. We get a response back, we get back an ID token again, and we get an access token, and then we shoot off to the back end with the access token. Okay, so that's what we want to drill into and actually see exactly, when this doesn't work, how do we deal with it, okay? So what we need are some troubleshooting tools, and one of my favorite tools is Fiddler. And in Fiddler, you can put things in called inspectors. And I've loaded in there an OIDC inspector, so I can actually look at the tokens. And I put a link in where you can actually download it from GitHub, and you can install it into Fiddler itself. And then it makes it a lot easier to translate the tokens. So actually, let me just zoom that, because I think it's probably a bit difficult to see from the back. So what we've got here is Let me just put that up like that. Okay, so what we've got is each of these is an HTTP session. So we hit OIDC Azure, and we come back, and that is, so we've got a request and a response going on. And then you can decide with Fiddler how you look at the data. So here I'm looking at the request as a header, and here I'm looking at the response. I could look at it as text, web view, whatever, but I've decided to use this OIDC inspector, and what it does is it gives me the code that we're getting back, and then it breaks open the ID token. So the code comes back as a lump and breaks open the ID token. And what the state is and everything else I will come to shortly. If you want to examine a token, one of the ways you can do it, there's a JSON-WebToken.io site, which has quite a nice token viewer. I wouldn't put a security-sensitive token up into a public website. So if you want to check out a security-sensitive token, there's a PowerShell script that will do it for you, and I've put a link up to that PowerShell script. So want to look inside the token, there's two ways of doing it. You could look at the body, because all it is it's base 64 encoded, but then it's much easier to use something like the PowerShell or to use the JSON-WebToken.io site to have a look. Fiddler acts as a man in the middle. So what actually happens is your browser communicates with WinINet. WinINet looks to see if there's a proxy that it should be using, and if there is, it goes through the proxy. So Fiddler puts itself in as a proxy. Now, if that was an HTTP request, no problem. But what we want to do is break open HTTPS. So Fiddler creates a spoof certificate. The browser will accept that spoof certificate because when you set Fiddler up to intercept HTTPS, you put a Fiddler certificate in your root store. So now the browser's absolutely happy to do that, and we are connecting up to our web server, but Fiddler is sitting as a man in the middle. It's terminating HTTPS and then remaking HTTPS. The problem with that is it's not going to be viable in certain situations. So one situation, you might have a company policy that says no HTTPS interception will happen in our organization. I think that's a little bit too draconian, but I've seen it. So I think the guys that are doing troubleshooting, to be able to use a tool like this, is very useful. But you have to be careful, of course. If you put this on a normal desktop, then you could actually go to a website where you don't want interception, and it's happening because you've left Fiddler running. And be very careful if someone sends you a Fiddler trace, saying, hey, look at this. I can't understand what's going on, all right? Just remember that if it's a Fiddler trace and you've gone up to Azure and you've authenticated, that user's username and password is in the trace. So I have a rule. I will never accept a trace from anyone until they say they have reset the password, because I don't want to be responsible. If they send me their username and password and then get hacked while I'm looking at it, I don't want to be anywhere near their password. So it's a rule. I will never accept a trace from someone unless they guarantee they've reset their password. So that's one thing, is the interception might be banned. The other thing is you might be going to a website that's implemented public key pinning. And this is uses a technique called TOFU. There is a Chromium project actually to allow public key pinned websites to be preloaded into a browser. But conceptually, what happens the first time you go up, it says we need to use public key pinning, and it tells you the certificates it's using. And now the browser will not accept any other certificates. So it would block the Fiddler interception. And then the next one is channel binding, or token binding as it's also called. And this is something Microsoft's moving forward with in terms of adding an extra layer of security to Azure. Because what happens is you put a token into a TLS tunnel. Right? And the problem is someone could intercept it, where you can use Fiddler to intercept it, and you can pull the token out and examine it and everything else, and then you could replay it and do all sorts of nasty things with it. With token binding, the token is actually bound to the TLS channel. All right? If it arrives at the other end, the token binding is checked. And if the token binding is not as expected, what will happen is your endpoint here will reject the token. All right? So if you put Fiddler in the middle, immediate token rejection. All right? So this is something that is going to be rolled out in the future, not too distant future, but I can't say more than that. All right? So that's channel binding. So if any of those three are in place, you need an alternate solution. So one of the things is to go out and buy a commercial piece of software, something like HTTP Watch. You can get extensions that go into browsers, but why not just hit F12 and use the developer tools? Developer tools actually do a pretty good job. If this is actually showing in Chrome, but you can also do it in other browsers. And number one, you tick the little box saying preserve logs. And what it will do is it will log everything that happens. And then you save it as a HAR, as in a HTTP archive file. And you can load a HAR into Fiddler. So you can actually look at it in Fiddler. HARs are lossy, so it doesn't save all the data, but actually it'll save enough data for you to be able to examine it in Fiddler and find out what's going on. Okay, so the first request to the STS, that is that. What I want to do is break that open and have a look to see what's going on. So off we go to the STS. So why are we going to the STS? Because we've hit the app, and the app says you're not authenticated. So off you go to the STS with all the instructions about what you need. And the first response, the first thing you look at that and you go, oh, wow, that's a lot of stuff. Well, the first thing is the endpoint. Where are we going to go to? So we've got to get the endpoint right. Next thing is we're supplying the client ID. That is the identifier of the application. The next thing is it's saying after you've authenticated the user and you've issued the tokens, return to this URL. And it's called a redirect URI. And what we have, the Azure AD will never, ever return to that URL unless it's configured up also in the portal. So here the client is saying, in the string it's saying return here, all right? But it's got to be set also in the portal to actually get the return. Because if it wasn't, it would be a complete security nightmare. Because I could throw a rogue website up and say, hey, persuade you to come and log in. You log in, and I tell Azure AD, produce a token and return here to the rogue website. All right? That it would be a real problem, because now I've got a token which I could then play against other people, or attempt to. So that's very important. We specify where to come back to, and it's very important it's specified in Azure AD. Next thing is response mode. How do you want the response back? Well, very typically is if you've got a website, the response mode coming back to that will be a post. So we're going to post back to the website the ID token and the code and one or two other bits and pieces. So that's the forms post. The response type is what you want back. I want a code, I want an ID token. So that's in there. We then got a scope, and I'm going to leave the scope. I just want to say, for the moment, OpenID means do OpenID Connect, right? But I will come back to the scope in more detail. State is just a state value that you set, and it needs to be unguessable. And what happens is, when you hit the app, and the app redirects you, it sets a state value in here. And when you get the reply back, the state value will be the same. So we've sent up a request, back comes the response, and we say, this response is in response to that request. So we can tie the request and the response back together. The other thing it's used for is prevention against cross-site forgery, right? Because again, we're setting the state. If we get a different state back, we just reject the token, all right? We're not gonna have it. We won't even do any checking on the token, just rejected. It's been forged, the request has been forged somewhere else, all right? So, and then there's this thing called a nonce, and a nonce is used for replay detection of the actual token. So when we send the request up, we're setting a nonce value. Again, it needs to be an unguessable value. And then when the reply comes back, the nonce will be actually inside the token, and it will be digitally signed. All right? So now we say, hey, we never sent that nonce, so this token must be being replayed from somewhere else. Right? So it's been captured somewhere else and being played against us. So again, we reject it. Really important that we do actually properly validate the token and validate the state and validate the nonce. So that's pretty much the first redirect. So where do we go to? Well, we need to go to some endpoints. And the way that we go to these endpoints is we go to this thing called .well-known OpenID configuration. And depending on whether you're using the V1 or the V2 endpoints, depends whether you've got, so it's login, microsoftonline.com, the tenant name, and then we either don't have v2.0 in, or we do have it, and it gives you the endpoints for the two different, well, they're not different protocols, but they're different versions. So let me just zoom this a bit. So what we've got in here is the authorization endpoint. That's where we go to get initially authorized. This is where we do a code to token exchange. And here's the response modes. So forms post is one method. If you're working, excuse me, if you're working with a single page application, you'll probably use a fragment because you want the response to go back into the browser and not back to the server. So a fragment, a URL fragment is where you have a hash in there. And then you can get it back in a query. I'm not going to go into all the details. You've got an end session endpoint in there. Oh, this one's very important. This is where, so when you get your JSON Web Token, in the header, it will tell you that this has been signed, and this is a key ID. So where do you get the public key to check the signature? You go to this endpoint and pull the public key from that location to check the signature. So these are very, very important to us, the discovery endpoints. And if you're familiar with sort of federation metadata, think of it in that way if you like. Okay, so what I want to do is drill into that first redirect. So I'm going to start off going into the first redirect. So let's just switch over on that. Okay, so I'm using Fiddler, so I'm going to clear off Fiddler and going to OIDC Azure, and I'm going in with hybrid flow, and oh, it's not sort of what I expected. It's very strange. The reason I've got this is, well, must have made a mistake somewhere. So let's have a look. We're getting back what it looks like. It sort of looks like the discovery endpoint data. Let's actually have a look to see what's going on. So I'm going to grab the request that's gone across, all right, and I'm going to, first of all, put it into the text wizard. Don't worry if you can't see the details of this at the moment. Going into the text wizard, and I'm just going to URL decode it. So I've got the, don't bother about the details, I'm going to put it in Notepad in a second. By doing a URL decode on it, it just makes it that much more readable. So what I'll do now is I'll grab that and I'm going to put it into Notepad. And that should be, I hope, big enough. Let me just break it up and then I'll check with you at the back whether you can see it. So we got our client ID, we've got our endpoint, our client ID, a redirect URI, which is where to go back to. We've got the forms post, which is the method that we wanted the token returned to us, and we're requesting an ID token and a code. So that, can you see that at the back okay? Yeah? Okay, great. It all looks correct, which is very weird. except something doesn't look quite correct. Anyone like to say what it is? It's a cut and paste mistake I've seen many a time. So this OpenID configuration, this is where we get our configuration. That's where we find the endpoints, all right? We're not going to the correct endpoint. We're actually going to this configuration. It's bringing down a JSON document and just displaying the JSON document to us. So what we need to do is we actually need to have a look in a bit more detail, and we're going to go across to the server. And on the server, what I've done is I've put the well-known point in here as the authorization endpoint, which is completely wrong. But it's a very common mistake that I've seen. So I'm going to drop that into Google. And by the way, I've got JSON view installed so I can view this. And what we can see is we've got the authorize endpoint, and that's what we should have picked up. So we've got the authorized, but it's also got all the other data that I sort of went through briefly before. So let's pick this up, and let's pop that, copy the link address, and pop it into our configuration over here. So now that's sorted that out, so we can save it, and then we need to go back to our Windows 10 device, and what we're going to do here is go again. So we'll clear that, close that, and off we go with hybrid flow. And oh, this is looking better. So we're now going to log in as John. And by the way, I always, when troubleshooting, I disable persistent cookies. Okay. Now this is another error message we got. Application with identifier, and then we got a GUID, was not found in the directory. Okay. So these messages, when you first see them, they look horrendous and you sort of ignore them. But actually, they're really meaningful. The application means either I haven't registered the application in the directory, or I've registered it in the wrong directory, or I'm going to the wrong directory. All right? Because what I'm doing is in that redirect string, I'm going to an authorization endpoint on a particular tenant. So I could be going to the wrong tenant and saying, please authenticate this user for this application. So we could be at the wrong tenant. Right? So what I need to do now is actually go back and check that and to see what's going on. But it's very easy to dismiss these error messages thinking, oh, I need to get Microsoft involved, whereas actually they're quite meaningful. So what I'm going to do, that is the ID of the tenant I'm using. I'm going to go over to the well-known configuration again. And what I'm going to do is rather than using a GUID, I could look the GUID up in the portal or with some PowerShell. I'm going to replace the GUID with any of my verified domain names. So 5.users.xtshub.com is a verified domain name. And there we are. We've actually got the configuration data for that tenant now. And I'm going to drop that in because that's where the mistake was. Okay, so that sorted that out. So we'll try it again. And again, very common mistake, going to the wrong tenant, especially if you've got lots of tenants involved. So off we go again. And we're going up to, we're using hybrid flow. We're going to use hybrid flow all the time. So off we go. And sign in as our user John again. Okay. Oh, the reply URL specified in the request does not match the reply URLs configured for the application. Okay, so again, it's very easy just to sort of dismiss these messages, but again, that's totally meaningful. It means I'm sending up here, I'm saying please reply here, and it's not configured up there. So either I've got it wrong in that string, all right, or I've got it wrong in the tenant. So what we need to do is now check that out, and I'm going to have a look to see where I've got that mistake. So looking here, that this is actually in the request string, that looks correct. So https oidcazure.example.com/post.php. So that looks correct. And of course, that is coming from the configuration of the application. So that's good. And so the next job is to go over to the tenant itself. And what I need to do is go into the app registration. And I'm going into the app registration up here. And I'm going to do it for my app in here. So let's just put in OIDC. And having put OIDC in there, I'm choose OIDC Azure, go to Settings, and let's see what's in here. Oh, it sort of looks right. Except, oh, it's got post instead of post. Computers are so picky, you'd think they'd got spell checker in them these days. So save that. And let's try once more. So this is pretty much everything you could have wrong with it is wrong with it, but you can go through it, you can iterate through it, and hopefully this time it's worked. So we're going with hybrid flow again. Login is our user, John, again. And we're in. Okay, so we have an ID token, and it's even got his name on it, John Williams. So that actually looks pretty good to me. So I'm happy with that now. So the next thing is to look at the first response after authentication. Now, what you can do is you're sending a request string up to Azure AD. What Azure AD will do is it will bounce around, doing all sorts of things. It's going to gather your username and your password. And you could go through and analyze all of that. And you could say, oh, that's how it does it. And then, of course, next week it does it somewhere slightly differently. There's a lot of Java going on to get the UI optimization. So basically, don't look at anything. What's going up to Azure AD and what's coming back. All the noise in between, just ignore it. You can waste so much time looking at it. So what I want to do now is actually look at the reply. But actually, maybe I don't want to look at the reply. What I've asked the protocol to do is to do the post. So really, I should probably be looking at the post back to my application. So the traditional way for doing this is when the reply comes back, you get a web page back, 200 OK, and you have a hidden form. Inside the hidden form is the code and the ID token, the state parameter, and so on. And down the bottom of the hidden form is a submit button. And there's a little bit of JavaScript. And if you watch the screen really, really carefully, right, you'll see a little hand come out of the screen and click the button to do an automatic submission. Right, so it automates the clicking of the button for us. And that, having clicked the button, it's a post back. So it's a hidden form with a post method. Where's it going to post it to? It's going to post it to the reply URL. Okay? And that's the way it has worked for years. I saw some changes the other day whereby the data was coming back with a whole bunch of JavaScript. And the JavaScript was actually doing the post back method. Right? So don't rely on there being a hidden form. If we look today, we'll probably have a hidden form. But in the future, you may find the hidden form isn't implemented. That's not part of the protocol. The part of the protocol is the post back. So hidden form just works beautifully as a post back method, but you can equally well do it with some Java to post back. So that's where we need to examine. So how do we examine the subsequent post? Well, one of the best ways in Fiddler is to actually use WebView. we use the web form view, and then we can see the code, the ID token, the state. There's a session state, which is also a state value that when you actually authenticate against Azure AD, you get that back as well. So that gives us a very nice way of examining what is going to be sent back to our application. Now, one of the things that we need absolutely to make sure of is that our tokens are being validated properly. And one of the things you can do is to check that validation, and what the audience should be checked, the issuer should be checked, the time should be checked for validation, but also equally well, and most importantly, the signature should be checked. So we can do some rudimentary checking to see if this is happening by using a fiddler breakpoint. So what we put in is a breakpoint, and then we make changes in our token and see what happens. So we could change the state value, for instance, which is not part of the token, but is the app responding properly to a state value that is incorrect? All right. So what I'm going to do is I'm actually going to fiddle with the token values itself. So to show you how to do that, what I'm going to do is I'm going to just, again, start off in Fiddler, clear that out. I want to get a capture first, so I'm going to go exactly the same way to my hybrid flow and get a complete capture. And having captured this thing, I can go back into Fiddler, and what I'm going to do, there's the post going back. So we can select that, and we can actually see the post and the details over there, okay? So looking at it in web form view. And I'm going to actually change a value in the ID token. To do that, what I need to do is set a breakpoint so I can stop it before it's submitted back to the app. So we add a rule, and we're going to add a rule in the rules editor, which is actually to set a breakpoint. And the Fiddler, you can do the most amazing stuff with, we can put a breakpoint before, we can put a breakpoint after, etc. So I've just set a breakpoint before the post back. When you're doing this, make sure that unmatched requests are passed through. So make sure you do that. So now what's going to happen is it's going to run to the breakpoint, and then it's going to stop. And so I have to save that because I've just set that rule up, and now we're ready to go. So we'll just minimize Fiddler. We'll close this off again, and we'll start again. So we're going to go in, and we're going to hybrid flow. And we're going in, and again, my user John, which is John Williams. And I've signed in, and notice we haven't got the page back, and Fiddler was flashing. It's hit the breakpoint. So we can now use the inspectors to look at what was going to be sent back, okay? So I can then switch to I can set unlock for editing. So I grab the ID token, take that, and I'm going to pop that into Notepad. And remember, the ID token is made up of 3 components. There's the header, the body, and the signature. So I've just pulled the body from between the 2 periods. Okay, and I'm now going to put that into the text wizard, and I'll show you this in a second. I'm going to base 64 decode it. So what I've done is I've got it's base 64 encoded in the top. That is just the body of the JSON Web Token, and below we can see the decode. Okay, so what I'm going to do is because I've got to re-encode this thing, I'm actually going to send the output to the input in the text wizard. I'm now going to, I've got a name in there of John Williams. Let's modify that. So we can take the name and we can modify it. And what should we have in here? Let me it's always difficulty is choosing suitable names. So we'll have Mary Jane. So John Williams has been replaced by Mary Jane. Now I'm going to encode it. So I'm going to go to base 64. So I've changed it to Mary Jane in there. So Mary Jane, you'll have to believe Jane's there, rather than me losing the focus again. And I've gone to base 64. Okay, so that's done. And my next job will be to take this, and I've got to put it back into Notepad because I need the header, I need the signature, drop that in there. And then I'm going to take this and I'm going to drop it back into this post. So in here, the ID token. So just drop that whole JSON web token back in there. And now what I can do is I can run to completion. So I've run the whole thing to completion, and I've got an ID token. Let's just clean this up, actually, for a second. So I've got an ID token back, and if you look carefully, you can see we've got Mary Jane inside the ID token. So what can we immediately conclude from that? What hasn't the developer done? Validated the signature, yes. So it's a very quick check to see if signatures are actually being validated. And you know, you can check the state value and all that, whether it's working. The other thing I sometimes try and get a developer to do is turn off signature validation. Have a method of doing that, so I can then check that the nonce values and things are all being responded to as well as part of a testing procedure. Okay, our next job is to convert the code to a token, and that's where this happens on the back channel. And if something goes wrong there, you can spend hours. So what you want is back channel tracing. So you want the developer to make sure that their code can go out through a proxy. Now, what you could do is put Fiddler up there, and you've got a proxy sitting up there, and you can go through Fiddler. The problem is, sometimes you're not allowed to have Fiddler up in the data center. Right? So what you can do is you can actually set up to allow remote computers to connect to Fiddler. And this is a very nice way. We've now got a remote proxy that we can connect to and do the tracing on that remote proxy. It's also a really nice technique. If you've got a mobile device, all right, set it up to use a proxy, and then put this somewhere else on your network, all right, and then you can actually capture everything from your mobile device because it's going out through the Fiddler proxy. So that's if you can run Fiddler on your server, but the important thing is to get your developers so that you can set a flag in the code and tell it to use a proxy to go out. And that way you can do back channel tracing. And as I say, if you've got a problem, it can save you absolutely hours. So the code to token exchange, let me just make that bigger again. The code to token exchange here is what we're going to ask for is it's authorization code, supplying a client ID, a redirect URI, just as before getting the ID token, a client secret this time, because what we're going up to and saying, hey, I've got this code, this is my ID, this is my password, give me back an access token. And because we're dealing with the V1 endpoints, we're asking for an access token back to a resource. And there's the code. And there's the reply, there's the access token, and there, and also down here, is metadata. So this was your question you asked earlier, is how do you do this? The metadata's there, so you don't need to look inside this token to realize it's for this resource, it's got these permissions on it, and this is the time validity of it. So there's the metadata. Okay, so back channel tracing. Let's actually do it. So I'm going to going to Fiddler here. I'm going to just remove this breakpoint because I don't want it anymore. Okay, so we just save that. And then what I'm going to do is I'm going to go to my OIDC Azure. And I'm going to go in with hybrid flow. And I'm going as my user John as normal. So I'll just log in there. And then we're in. We got the ID token. Let's convert the code to token. But before we do, I want to go over to the server. And I've got back channel tracing enabled. I'm going to clear Fiddler on the server. And now I convert code to token. And it fails. Right. If you've only got the capability of doing front-end tracing, you now have to rely on the developer actually creating a log of any error messages they're getting back from Azure AD. And quite often that doesn't happen. But if you've got back channel tracing on, you can simply go to the back channel trace and see what's going on. And what we can see is the grant type being asked for. Okay, so we've got all that information, just as we saw previously, I showed you. And then it's a 401 unauthorized, and you go, why is it unauthorized? Well, the really nice thing is you've got the ability to look at the JSON document that's returned, and there it is. We've got invalid client credentials provided, okay? Now, if the developer logged that for you in a log file, then you could have looked in the log file, but quite often I see these things not being logged. Therefore, having back channel tracing in, we now know exactly what the problem is. The client secret's invalid. So what we need to do is go back into the Azure portal and get the client secret. Only problem is you can't. Once you've got it the first time, you can't get it again. So what we need to do is simply gen a new client secret. So I'm going to go in there, give it a duration of a couple of years, and then generate that, which happens when you click save. And then I'm going to grab that client secret. This is the only time it will appear in the portal. And actually, let's just get rid of those old keys, because just chuck them out. Okay, so now we've grabbed the client secret, we've done that, and now what we need to do is we need to go back to the application configuration, and we need to drop the secret in here, which is called the key from Microsoft. It happens to be called the password in this application. And then having done that, what we do is we click save on there, obviously, and then go back onto our client machine, and we try again. Okay, so we'll close that off and go in once again. So again, we use the same user, and right, convert code to token. And that looks like it was successful. Yes, we've converted it successfully. All right, so that's good news. Let's just have a look over the, and we can see that we got user read on that as a scope. Look over here, and what we see is we've successfully got back an access token, we got an ID token, we got a refresh token, and we've got the metadata back. And these tokens we store them in cache, and we use the metadata to know if they're valid or not from cache. Okay, so we're getting there. We've got an access token back now to our backend API, and then we access the API, and we find it doesn't work. So how do we test that and troubleshoot that? Well, one of the best ways of doing that, and my favorite tool, is using Postman. And the really great thing about Postman is you can figure out how you call the backend web API, And having figured it out, you can save it as part of a Postman collection. So you can completely document your web API call with code that actually works, that you can just pull out of a collection and use and play against the API. So it's a very, very powerful tool. And let me just really quickly show you that. And so I'm going to access the API here, but we want the access token. So I'm going to grab that. And then having got the access token that I got back previously, I'm going to go to Postman. And having started Postman, come on Postman, hurry up. What we can do is we can call the API and use that access token. So I've got the call to the Graph API set up here. And if we look at that, what I'm going to is graph.windows.net, my organization, me being the person the token was issued to. So what I can do is take that access token, I can drop it in here. And what you need to be careful is there is not a new line on the end of the token, and I send that off. And now I've sent that off, I've actually accessed the Graph API using the access token I got back. And somewhere down here, we'll find the user is John Williams. And in here, we can actually see these come from an on-prem. So he's actually an on-prem. He's a hybrid user having come up from on-prem. And that's the joy of using Postman, is it gives you a really quick way of checking and getting access to an API. And you might have to fiddle with it a bit to get it working, but having fiddled with it and got it working, save it as a collection and send the collection off to someone else for them to work with. Right? And a number of companies are using Postman to document their APIs. So if you look on some companies' websites, they'll describe their APIs, and then there will be a Postman collection to go with them. And you can just download the Postman collection, start using the APIs directly. Postman, by the way, will let you go off and get an ID token, access token. You can do the whole thing with Postman. Okay, troubleshooting consent. We need to understand a little bit about the apps registration blade. In the apps registration blade, what you're actually doing is creating a template for an application. It's not actually an instance of the application. So we create it, configuring it through the UI, and also configuring it with a manifest. The first time that application is used, it creates a service principal object. That service principal object we actually see in the Enterprise Applications blade. So when you look in the Enterprise Applications blade, you're actually looking at service principals. Okay? And why do we have this method of doing it? Well, one of the reasons is multi-tenant apps. So we have a template in one tenant, and that app can be used in lots of different tenants. So a service principal gets instantiated in the different tenants. Not time to go into multi-tenant apps here, but that's sort of one of the reasons the template is there. But just remember, template in the application registration blade. When you create an instance, it's in the enterprise blade, and that's a service principal. Now, we saw this slide yesterday. V1 endpoints, we are setting up a static definition between the app and the backend APIs. Right? It's statically defined, so you're going to resource 1, we want read, resource 2, we want read write, resource 3, we want delete. All right? And when the access token is requested, you don't request it using a permission. You say, I want to go an access token to a particular resource. What permissions are going to be in that token are statically defined, which means you create quite an issue. Number one is regardless of which token you want to go to which backend resource, when the user has to consent, they have to consent to all the static permissions. Number two, as an issue, as an app developer, you need to know all the statics you want, right, when you first configure the app into the portal. And if you've made a mistake,
and the app's already been used. What you have to do is blow away consent and start again. So we need to actually blow the consent away, and then everyone will have to reconsent with the new permissions. And how are the permissions held? They're actually held in an OAuth2 permission grant object. There are 5 components of that object. Number 1 is a consent type. And the consent type is either principal or all principals. If it's principal, it means a user has consented to this. If it's all principals, it means an administrator has consented on behalf of absolutely everyone. So no one's going to be prompted. Right? So in this particular case, I'm choosing principal. Next thing, if you've chosen principal, you need to say who the principal is. So you've got the object ID of the user. So my principal here is John. The next thing is you've got the front-end application. And what you need, so this is the client ID, the front end, and you use the object ID of the service principal that represents the front end. So that now is app 1. The next thing you'll need is what permissions you've consented to, and you need the object ID of the back end. So now we've got this situation where this John has consented to app 1 having read access to app 2. And this is how the consented permissions are held. And obviously, there can be an awful lot of them, right? But if you destroy the service principal, they all disappear. So it's one of the quickest ways of cleaning them all out. Just kill the service principal. Next time the app's used, new service principal will be created, and everyone will have to consent again. You can enumerate the consents with PowerShell. And as I said yesterday, up until a couple of weeks ago, you used to have getInfo in the My App, so a user could see what they consented to. GetInfo has now disappeared. The reason being, it was actually enumerating the static consents, not the actual consents. That's going to be fixed fairly shortly. Look out, there's going to be a completely new My App experience. Look for that in preview when it comes out. And this should be fixed in that. If you go to the Enterprise Application Blade, you can look at an application and you can see all the consents that are there. And in this particular case, you can see that, yes, you sort of, well, I'll just zoom in on that, is you can see over here, we've actually got, this is a total of 1 user has granted this particular consent to the application. Of course, multiple users could consent. If you click on the users, you see which users there are. But if we look at admin consents, at the moment, it just says it was consented to by an administrator. And we don't know who the administrator is. In the future, that will change. But for the moment, we can't tell. And partly the reason, if we just go back a few slides, is when we go all principals, we don't specify principal. All right, so administrators consented for this to happen, to have all principals in there, but there's no principal listed. But those two are very useful in the UI. If you want to view via PowerShell, you've got a relationship between the OAuth2 permission grant object. So here, the client ID is the application, the front end. The resource ID is the back end, and then what we've got in there is an object ID for John, which is the principal, and insert there we've got the permission that's been granted or consented to. And notice the consent type in there is principal. Why? Because a user has consented to this. If you go for the OAuth2 permission grant for when an administrator has consented, notice the consent type is all principals and the principal ID is blank. All right? But exactly the same relationship works with the resource, the scope, and also the application. Now, an administrator can consent on all behalf of all users. There's 2 ways of doing it. You can do it through the UI. You can click on the Grant Permissions button. That does it for you. The other way to do it is to go to a consent endpoint. The consent endpoint for V1 was, when you send that string up, you say prompt equals admin consent. You add it to the string. if you're using V2, and actually now this works in V1 as well, you can go to a different endpoint, and the endpoint ends in admin consent. All right? So we go up to authenticate, but we're actually, or it's authorize endpoint, but it actually has admin consent on the end of it. I'm not going to go through this. I've just put it in the slide deck. This is PowerShell to get you started. By the way, somebody asked me about the slide deck. They should be, I saw some people tweeting last night saying they were downloadable. So you should be able to find these. And I've literally just put that in there as a way of enumerating out all the consents that have been given. If you want to remove consent, the way we remove consent, we can do it for a user. And the way you do it, you go into the My Apps portal, you delete the application in the My Apps. And that just blows away the consent for you. All right? You could do it with PowerShell. So you could enumerate it out. So that is a user doing it by going into My Apps, because that's the user's portal. Right? If you as an administrator want to blow away consents for a user, you can use remove Azure-AD OAuth2 permission grant. And you could do that. If you want to blow away absolutely everything, quickest possible way, just kill the service principal. All consents have gone. But equally well, all users you've assigned to that app have gone as well. Not the users, obviously, but the assignment to the application. So the other way is to enumerate through and removing with PowerShell as well. With V2, remember, what we're not doing with V2 is we're not predefining static consents. So we can request now, with V2, we can say, we don't say, V1, remember, static consents, and say, I want an access token to that resource. And you get the permissions that are defined for that static consent for that resource. With V2, what we say is in the scope field, we say we want to go to this resource with this permission. All right? So if you look down there, what it consists of is a resource, a subject, dot permission, and then possibly a dot and a modifier. So the example I've given in there is graph.microsoft.com, and then the subject is directory, and we're going to read, write, and it's for all, okay? So that's the way we request them. But just because you've got it in your access token doesn't mean you can do it, all right? So if I say, oh yeah, John, read, write, all, or whatever, all right, I get it in my access token, I arrive here at Graph, and Graph says, hang on a minute, before you can do that, you've got to be in the appropriate Azure AD role. Are you? So there's a second authorization check that happens there. So I'll just do a very, very quick demo of just looking at troubleshooting consent. And I'm going to go off into my OIDC Azure, and we know that when we sign in here, we're not actually being prompted, but just to remind ourselves, we go in, and this is a V1 endpoint. We've got our ID token. We do a code to token exchange, and what we've asked for is a access token to graph.windows.net, and whatever's statically defined is what we've got back. And statically defined in here at the moment in the scope parameter is user.read. Okay, so that's the current situation. And what we'll do in here is we'll just go into the My Apps portal, and we should see this guy in there. So there he is, OIDC Azure, and we click on there, and there's no get info. That's gone. Right, it was there, say, a couple of weeks ago. Right, let's go into the directory itself. But before we do that, what I want to do is just enumerate the consents. So I'm just going to enumerate consent here. And I'm using my little PowerShell script. By the way, this is broken. It sort of basically uses what I've put in the slides, but I've already got it pre-configured to look at particular consents for particular people against particular applications. So I'm just connecting to Azure AD. And then what I'm going to look at is I'm going to look at the consents in here for John to OIDC Azure. So I'm just presetting my principals in, etc., and the service principal for the app. And what it's saying in here is I've actually got here we've got to Windows Azure Active Directory, you've got user.read, and to Office 365 Exchange Online, I've got mailbox settings.read. So that's currently what I've got. Now, if I go in and make a change to that, and I can do that obviously in the main portal, so I need to go to required permissions in here. And I'm going to, first of all, do the Exchange Online and just change the required permissions on that. And I'm going to choose in here, user read at shared calendars. And notice this thing, it says, you are adding permissions to your application. Users will not have to consent. So users will have to consent even if they've already done so previously. That is not totally true. We've got to destroy what they've already consented to before they're going to be prompted again. So let's go and add an extra one in here for the Windows Azure Active Directory. So we'll just come in here and we'll save that. So let's save that as well. So we got 2 permissions into Exchange, 2 permissions into Azure AD. Now, if we come back over here and we close this off and go back in as John, okay, so we're going into hybrid flow as John. And log in, sign in there. And we're in. Okay, but if we look at the token has got exactly what it had on before, user.read. And we haven't been prompted to consent. Okay, so what we've got to do to be prompted to consent, we've actually got to blow away the consent object. But if we look at this, we've got exactly as we had before. So we need to actually blow the consent object away. We could do it with PowerShell, but we'll get John to do it for us, and we'll go into the My Apps portal to do that. And we're going to destroy this or remove it. Okay, so if I wanted to do it for every user, I would go in and I could go into the Enterprise Application Blade and just delete the service principal. If we have a look in here now, it should have gone, but you've got to realize when you're working with Azure, any cloud service, there's normally a latency of some kind. So they haven't gone at the moment, but hopefully they will have done in a few seconds. Let's just give it a little bit of time to cook, and we'll try it again. Yep, they've gone. Okay, so now let's go back in again and go back into Azure, the OIDC Azure, and we should be prompted, to actually ask for absolutely all the permissions. Yeah, so we've now got read all user basic profiles, etc., read the mailbox, and read the calendar. Okay, so that's how we get consent working. There's, so just to sort of sum up, there's a bit of a documentation nightmare. If you're trying to learn OAuth2, you're trying to lose OpenID Connect, because OpenID Connect should be the same across all vendors. OAuth2 definitely isn't, right? So if you read somebody's documentation, they'll be, implemented this way. Somebody else will implement it that way. The basic core principles are the same. If you read documentation, make sure you're reading the OAuth2 documentation. Make sure you're reading the OpenID Connect documentation. If you're reading stuff on the internet about how it works, be careful. There's a lot of misinformation on the internet about how the protocols actually work. Do absolutely check that your developers are not leaving loopholes. check signature validation, check replay detection, check cross-site script forgery, check they are not accepting a token unless it's for them. It's for that particular audience. So there's a lot that needs to be checked to really make sure that you're completely secure. Top tip, always start with a trace. Tracing puts you in a really superb position to resolve issues in minutes. Without a trace, you can find, time, it's an hour, before you know it, you haven't fixed it the next day yet. But a trace will just give you the answer like that. And so do look at it, do get yourself in a position where you can have back channel tracing as well. And with back channel tracing and front channel tracing, you're really in a very, very powerful position to actually authenticate. There's a masterclass where actually a lot of the example, the codes and things comes from that. If you're interested in it, by all means, have a look at our website. And the other thing is just to say, please, as before, do fill your evaluations in. They're so important. And thank you for actually, yesterday, some people put some amazing comments. And thank you very much for those. I really appreciate it. Thank you. And thanks for coming.